Hey guys, how's everything going? Today, let's take a look at number 97 of LeetCode, interleaving string. Interleaving. This is the first time I heard of this word. We're given an S and S2, S3. We have two strings. We find whether S3 is formed by the interleaving of S1 and S2. Interleaving. Okay, A, B, B, C, C, D, D, B, B, A, D, B, B, blah, blah, blah. Okay, it's true. So this one is A, B, C, C, D, B, B, C, A, D, B. So let me get this straight. The interleaving means we cross these two words together, right? With the order conserved, reserved, conserve, reserve, conservative, reserve. Yeah, reserved. Okay. I think this could be yeah. So let's analyze the simple cases. Let's say A, B, C, C. Okay, and the other one is D, B, B, C, A. If we're going to interleave these two words, we're going to put some letters of B to the position the head or the rear of the first words, or to the space between these two words, right? So like D here, B here, or D, B here, something like this, right? So, and if we get the result of this interleaving, we can know a characteristic of this this transformation is that, look at the head. If we do the interleaving, if we put D behind A, the result will start with A, right? If D put before A, it will start with D. So the beginning of this digit would be A or D, right? So if it is A, then the rest would be an interleaved result with the string here and the rest string of the first string, excluding the first letter. Well, this reminds us of a very intuitive recursive solution, right? If first letter is this one, then we just continue checking the rest string of S1. If it is S2, then we check the rest of S2 with S1, right? Yeah, cool. So it's similar to what we did before. We use 3 pointers to stand for the start of the substring, right? Let's say, okay. As always, I'll create a recursion function called walk ijk, which means the start of the substring of each of these 3. Okay, and then we will return walk 0, 0, 0, means compare them from the start of the words, right? Okay. Every time we walk on specific index, which means this specific 3 strings. First we check if the first 2 is the same, right? Okay, this will return true if either of them matches. So return S1I equals S3K. If they are the same, A, then we check the rest, right? So the rest is walk I plus 1, J, and K. This is the first case, or the second one, we check it against S2. Okay, I'll copy this. Okay, I'll just write it again. S2, J equals S3, K, and walk I, J plus 1, K. Alright, okay, so when will it end? Well, so let's analyze our example again. When we check to C or go to A, the last words, right? It's SC, A, C. We will check C again, and then go to check the empty string, right? Check empty string. and A is gone, right? I think so. Empty string, C. This must be empty, and then here is C again. So the ending must be the S3 is checked. S3 is done, right? When S3 is done, the result is done. The result is given. So if K is empty, which means K equals S3.length, we will check the result. The only true is that both of the S1 and S2 have ended. So we will return I equals S1.length and J equals S2.length. If the other cases, which means there is a letter left, then it is false. Okay, so I think we're done, right? Let's run the code. Oh, we're wrong. We're wrong. Where did we do wrong? Okay, start S. If K is checked, is empty. Wow, I'm sorry. There's another case that when the both of them are when S1 is done but S3 is not done. So both of them are done, and there's still letters in S3. How could we do that? How could we avoid that? It means if S1.length, okay, I'm bad, my bad. We will check the, oh, is this good? Yeah, just to do the reverse one, we'll return this. Okay, let's run again. Oh, it's still false. 0. Well, for this case, we will just log the result. Log the S1 slice I, S2 slice J, S3 slice K. Well, I think maybe we could just well, I think we just do something cool. We'll just filter out the irregular cases. If S like S1.length plus S2.length is not S3.length, then we return false. There's no need for us to check. If that's the case, every time we move a letter, K will always be a letter, right? So if that's the case, I think there is no need to check this, or there is. When we go to here, it means letters are checked. So yeah. If K is met, with the end of S3, return true. Still, we failed. What? I S2 slice J S3 slice K. Oh my bad, there should be +1 here, my god. Great, let's submit. So at the same time, we will analyze the time and space complexity. Okay, we are accepted, but not that fast. Let's time with every time we move a letter forward for K. We will walk it again. So either way, walk it again, and then walk it again. If one of them is true, then it is false, so we can ignore it. Wow, this, I think, time. Let's just use a string that, let's just, I think it's this, almost, because either one of them is true, right? If for K, so it's actually the same as it's actually, we can simplify it with comparing two strings, right, to the n. So we check this one and then compare this one, compare this one. So fn would be equal so we will check these two. Every round we will move one letter away. Remove one letter. So A is gone, and then compare these to these substrings, and yeah, compare. So actually, every letter of K is checked once, I think. So the time complexity would be O big O n. There is no sum or something, because only we check this. So this is actually I don't know, a tail recursion. I don't know. Yeah, I think time is a linear time, but space, this will be a call stack. So there's nothing more used. So the space is also linear time. Every walk we will reduce one. It will stop when it does not match. If this is true, we will compare the next one. If not, we'll go to this one. For the worst case, what is the worst case? We've already filtered out the irregular cases. I think so. So let's try to improve this one. The problem is that, like when we are checking, when we are checking this I and J, we might check like this A with this A, and we might check it over and over again. So this every round of the recursion reminds us we could catch the result of this I, J, K, right? And because we were figuring out the unmatched strings, this ij actually has a characteristic which means k equals the sum of these two numbers. So this leads us to the second solution, which is the memoization. But if we can improve by memoization, it means this is not linear time. So I'll add a question mark here. Maybe it's not. Please search. Please do the investigation for me. I really don't know what the time complexity here. I should be walk this compare this one, and then we'll check these three. Then it fails, and if this fails, we will check this again, and then go to this one. If they're both the same, then this will be A. I don't know. Anyway, let's try to cache the result. Let's use a cache, which is very simple. Const cache equals new map. The key would be I J, right? So if these already if cache get key, return cache get key. I mean hat. And this would be the result. Before we return, we need to set it to the cache. Set key result, and then we return the result. Yeah, we're done. With this, we can avoid unnecessary unnecessary calculations by memorizing the result. Let's submit. Actually, the time and the space. Wow, we are faster than 96%. So actually, there is some improvement here, which means this linear time is not true. So and then what is it? Let's say the worst case. What is the worst case? Like say there's A, and then there's a B, right? So when we checking this one, they are the same. So we're checking these two and these three. And of course, they will fail. Of course, they will match and then fail, right? So this A could not be true. Oh no, this yeah. So if say let's this word be checked against this here, it's matched and it failed, so it will check this and this one, right? And it will fail. And then we will check A here, so we will check this one and this one. So it will check this one and this one again. So actually, they will be checked multiple times, but this will be checked multiple times. It's not linear, so we will use if we use memoization, we can improve it to big O linear. Is it linear? Of course it's not linear. Oh, it's not linear. Yeah. Of course it's not linear. And the worst case is that we will check against every pair. Right? Every pair, that would be checking this against this one, and this against this one, and this against this one. And the last one doesn't match, so generally it's all possible. It's all possible pairs, so it's O squared, N squared, and then ON squared, and it's let's say all A, so it's actually the possibilities, these possibilities of all, no, let's say if this match, and then it would be like this, right? So Fnm would be Fn minus 1, Fn, this m, this is n, so Fn minus 1, and Fm plus Fn m minus 1, and this will be this minus 1 or this minus 1, right? So F minus 2 m plus F n minus 1 m minus 1 plus F n minus 1 m minus 1 plus F n m minus 2. Yeah, if we consider these if we consider m doesn't matter and treat them always n, they are the same length, generally it would be n, 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 and n. So it's actually 2 times F n minus 1 n minus 1 plus F n n minus 2. Okay, so Fn, so each of them minus 1 or one of them minus 2, right? So it become 2 times 2 here would be, wow, it's pure math. F means n would be plus 2 times both of minus 1 and minus F n minus 1 and minus 2. So this should be 4 plus F n minus 2 n minus 4 plus F n minus 1 n minus 3 plus F n minus blah 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 F n. Oh, there's a mistake here. I shouldn't do this. The order matters or not, because we need to define which one we need to minus 0 minus 2, right? Oh, it doesn't matter. Okay, so let's just put the latter one. So it would be minus 1 n and n minus 4. And this is smaller than 2 of this one. This will be, oh man, this is hard. I would say from this one, what is it? If we do some simplification, this must be smaller than 2. This one should be smaller than this one. Would it? Maybe the same? Might be bigger? Bigger? The biggest one of the possibilities will be when they are the same, right? 2 times 2 is bigger 1 times 3. So it's smaller than 4 if n minus 1 n minus 1. So I'm not sure I'm getting this right. So it should be so 4 2 to the power pole of n. Wow! Yay! We get the time of 4. Maybe it's right, maybe it's wrong. Anyway, let's try the memoization because we cache it, right? So every key will be actually counted only once, right? So once we calculated all the possibilities, we will return the result right away. Yeah, so actually it would be, how many possibilities are there? If there are the length of n, so it's n cubed, n the square. Wow, we improved. And the space, of course, the space we are using, we cache the result, right? We use n squared. Could we do better? Yeah, we actually here we use the extra space called the call stack, linear. We could improve it by dynamic programming, by recursion, where we do removing the head and compare the rest, right? But actually, we can just derive the result by how to say, reducing the rare. Just let's add. So basically, every recursion could be rewritten in, generally it could be written in dynamic programming. Let's see how it works. Let's again we analyze the results. Analyze the example. We're going to compare these three. We first look at the first letter, right? So for A, it must be of this A or this D. For this AA, it must be this AA and or AD or DB, right? So the problem becomes all the possibilities if they could generate the right result. For this question, we know that this AA plus this empty could generate these 2A, right? So now we if we look at the problem in a reversed way, for the last C, we only say these could be generated if C, because this C is the same, so it only could be this and this could be interleaved to this string, right? So if it is the same, we could do the same for this substring. But this substring is a subs problem, right? So the problem becomes this, could this be interleaved? And the index will be, if we add the check here, the index will match exactly. So the problem becomes if I from S1 and J from S2 could be interleaved into S3, I, J, K, right? We can just do what we did here in the recursion. We catch the result, and we will just do it very fast. Let's define the f function, f, which means here Si and J, Fi J equals if how to say, there are two possibilities. It means Fi minus 1 J if S1 n, if S1's end matches, or it's F, because we're only returning a boolean, so it doesn't matter about the count or something. J minus 1 if S2 and matches. So the problem becomes we will calculate these two, right? Yeah, cool. Let's just do that. Okay, if the length doesn't match, return false, and now we need to generate the two-dimensional array, which means cache. I will generate it with new array s1.length and the field with false, no, 0, and match it with a new array s2.length, and the field, because true is primitive, so we fill with false. We maybe use match field. Oh, what does field return? Let's see. New array 10 field 0. Return the array itself. Okay, so it's okay. So return new array field. Yeah, so this is the cache result, and then we will traverse through all the possible I and possible J. Let I equals 0. Now, so we need to calculate what to calculate. SR cached IJ would be what? Would be, okay, what would be what we did here. Yeah, so it means if the first one ends, which is SI, is equal to S3 I plus J, if they're the same, we will say cache I is the same, so I minus 1 J, right? Oh, if I start to 0, then this would be empty. For the start, A and 0, 0, Oh well, the index should be 0 here, this, and this, and this. And then this is 1. Right? Wait a second. This one, 0, 0, 0. Okay. We better add an empty head. We'll do that later. So if this case, or S2j equals S3I plus j and cache I j minus 1. And finally, we could return cache s1.length minus 1, s2.length minus 1. Yeah, this should be it should be theoretically right, but there's a problem of empty index. If we start 0a and d, zero zero, and so we're gonna be 0 0. Oh, it should not be 0 0. It should be 1 1, and this should be 2. And 0 0 would be this year 0. So my bad. It should be length plus 1. Fill with 0, match this, and this should be also plus 1. And we need to generate the first row of all zeros to the first row and the first column to 0, to false. No. We should only generate the first one. Yeah. Cache 0 and 0 to true. So now we're here with 1, 1. Here would be plus 1, plus 1, and here would be this. 0, 0, 0, 0 will be true, but 0, 1, it will be different. If that's the case, we should say 0 start with 0, right? If I is 0, and okay, we don't need to cache this one. J, if all of both of them are 0, we will just set it to 0. To true, yeah, and continue. Now j will be 1, so j will be moved here, and s1 0. So Sij would be, if they are the same, of course. Oh, if one of them is 0, it's gonna be different topic. For the 0, this will be 1 here. For 1, it would be wait si 0 0, yes, it's true. 0 1 would be 0 but we should skip 0. Yeah, we should start with 1. And cache 0, 0 would be true. Okay, cache ij would be is -1. I plus j, plus 1, -1. And cache I -1j, or this cache I plus j -1. Yeah, so okay, for 0, 0, 1, okay, for 1, 1, 0 does not match, we can skip. And then if j -1, if a matches a, yeah, and then cache 0, 0, 1, if that's true. Uh, 0, 1. So actually we need to initialize really initialized by 0. From 0, if I is 0, if I is 0, so it will only be checked. How should we handle the starting? Oh my god. If I 0, we start with 0, so empty, empty, and then empty. Of course, we matched. So, and then we check empty, D, and A. We compare that. Empty, A, no, we skip. And D and A, it doesn't, so we skip. But if it matches, it will gonna be 0, 0. Oh, so it's actually actually it will do. True. Yeah, like say 0, 1, because for 0, 0, 1, 0, 0. Yeah. If I equals 0 and j equals 0, cache I and j equals true, and continue. Right? And then we go to 0, 1, 0, 1. Because this is not true, we skip, and then checking the first one and the first one. So it should here by -1. If the same, okay, we will go to 0, 0. Oh yeah, I think this one does. It will do the work. Let's run the code. Something wrong here. I hope it. Oh, of course it's not. Fill match. Oh, not match, but map. Oh, it seems we accepted. Oh man, come on. Yay! But yeah, we're not that fast enough. Let's try it again. Sometimes just the machine doesn't work that well. Wow, it's not that fast. Well, let's analyze the time complexity. The time complexity would be we would actually calculate all the possible pairs of ij. So it will be the same and square. Space, just like what we did in the memoization, we use an array to keep track of the results. So it's also so it doesn't change that much from the recursion. We just transform it into another form of writing it. But the idea is different. For memoization, we are deducting the result directly from the recursion, but we are only caching the result with the key. We can generate it from anything. We can use ij or we can use ijk. It doesn't matter if it is unique. So this is much easier to think of. But if we rewrite it into a dynamic programming problem, we need to think as how we can do it iteratively. Like we need to deduct this formula first. Fij means -1 and this. So we can just calculate these suboptimal questions and just keep calculating and finally get ij. But for memoization, it's different. So every time we calculate something, we will we cache the result. So next time when we calculate again, we can return it directly. So the idea is different, but maybe the outcome is the same. Okay, so that's all for this problem. So it takes about 15 minutes. It's a little long. We are using 3 different approaches to this problem, so I hope it helps you. Anyway, I'm going to prepare for more detailed Java front-end technical review, a technical preparation for another interview. So yeah, maybe I'll create some videos more about the web, about the browser, about the JavaScript. It's maybe less about algorithms recently. So stay tuned, man. Yeah, that's all. Have a nice day. Bye bye.